Okay. Yeah, it's recording now. And okay. And I will put my my topic on the coder pad, so you can see that. Do you guys have access to my coder pad? Okay, good. Okay. Yeah, basically we want to design a cron job, and my requirement is that basic requirement is a new cron job is scheduled every second. There will be a 0.1 new job scheduled, and the average.
So the question is why cron job?
What do you mean why cron job?
Like why we are building a cron job? Can I live without a cron job?
This cron, the reason why I say that cron job is that this is something, just a name, and actually this is more like a distributed cron job that we need to assign the job into different machines. Maybe I can put the code.
No, so basically we directly jumped on the frequency. But before that, I want to understand what exactly is the cron job, like what we are doing. So
okay.
cron job could be different to different, like it's for me it's right now quite ambiguous. It could be different understanding to different person.
Okay, maybe we can change the name. Maybe we change the job scheduler.
Job scheduler, okay.
Yeah, and then we can assign the job into different machine to let them run. So yeah, this is the basic idea.
So basically, this will take a job, and any job.
Yeah, any job, like periodically do some canaries and to check the system, or we can have something like a job like the MapReduce style job that run every day in a certain time, and will run for a long time to process data. So any kind.
So basically, it should take any kind of input. That's what we are targeting. I'm just trying.
Yeah, any kind of job.
Okay.
So yeah, it's basically a piece of.
Do you have any close example of that?
One example maybe, just like I mentioned before, we can think about that it's like a MapReduce job. That every day, every hour, we have a lot of data in our somewhere in some file system, and every hour we pull the data from the file system and process.
So, but that MapReduce job is like again, it is very much specific. If it is a Hadoop system, then it will be for Hadoop. But I can't design a very generic MapReduce which can take any system.
Yeah, so that's not specific to the MapReduce.
No. What I'm saying, like, is it fine to assume like I'm designing a job which can take any input, any parameters, or very basic trying to solve very basic thing, like, okay, for specific, it could be like a program, Java program, which will get executed after a few seconds, or it could be like a Lambda, which will get invoked after, or it could be like a cloud function, which could be invoked after this much seconds or whatever.
Yeah, exactly. I think that's also a good example.
Yeah, because I want to I don't want like any, like I want to understand like what I'm trying to solve here.
Okay, so
I think Aseem, I think it's agnostic to what you are doing, like what the job is like. So rather than manually every day remembering, so let's say a simple exe, right? In a Windows, let's say it's a simple exe. Let's say remembering that I have to run this exe every day at 12 a.m. Giving a task to a scheduler that, hey, this is my code. It could be a script, it could be an API call somewhere, anything. I'm just saying that whatever it is, just execute it on this schedule, whatever schedule I'm providing.
Agree, Abhishek. Like I understood that it's a job scheduler, but I'm trying to understand why I'm making it.
Okay.
Who are my customers? Who is going to use it?
Yeah.
Or
Okay.
because this is something like even if I'm going to design any system at work, and
Mhm.
if my colleague will say again, I will ask the same question: why we are
Okay.
building this?
Okay.
Who is going
So
to use it? Like Abhishek, we all already seen there are a lot of examples. It could be like running a EXE or a Lambda or a MapReduce job. Is it like based on your guys' experience, it is fine to have a system design where I can assume anything I will do, or it's code like really specific?
in this case, we assume that it's for general purpose, but we can, yeah, if we go deeper, we can assume that this is, yeah, maybe we can say that this is for a Lambda system.
Yeah.
That need to run a Lambda function inside Docker and in some pattern of time, like every 5 minutes, every day, every hour, such a case.
Yeah, I will say let's take some one use
Yeah,
case.
let's take one thing and maybe a very simple thing so that it's for brain, it's easier to think about it. And then we can expand it to then we can see if we can expand it to other things. But
So,
I agree with Aseem that let's pick a simple thing. Let's pick a simple task and do.
so let's say it's a schedule job which will call a API. That's it. Okay.
Yeah. I'm thinking about calling for volunteer, but it seems that you are going volunteer.
But basically, I think generally cron jobs generally do something which is a big task. Like it takes some time to process. Like you're doing large amount of processing, right? In my experience, it's not just a single call or something. Am I right?
Agree. It depends what I have seen things like you're right. I've seen different things. For example, uh, I there was
Hello,
something that
1, 2,
Go
3.
pipeline. If anybody has worked, so there are cron jobs. So what it does, it invokes a process and be done with that. It could be an API call, whatever it wants to do. Or we can make it really simple. I think a job which takes a script, a bash script, and it does some work. That's it.
Hello,
In the same,
1,
let's
2,
assume that our job
1.
takes some time to complete, like 2 to 3 minutes. It's not just a call, so that our design is based on that our task takes some time. It's not like just.
And actually, that's a good point, because if you're you have another job schedule after 3 minutes and your job is not completed, what you will do?
Yeah, exactly.
Yeah, that's a kind of chain. Yeah, we don't need to design it here. We can assume that we can have an API to just trigger a new job.
It could be anything. I think for simplicity, it could be API, or it take a bash script and be done for now.
Yeah. Okay, do you want to try?
You want me to try that? Okay, I can try. You want me to try here or on the whiteboard link you're saying?
Yeah, you can use the coder pad to type any text, and if you want to draw anything, you can use the whiteboard, the AWW app, because it's very easy, convenient for me actually.
The one you have sent?
Yeah, I sent in the Discord, and also you may see that in the chat. And can you when you're writing, can you share your screen?
Sure. Okay, let me share my screen first. Please let me know when you can see my screen. You can use the whiteboard.
I can see.
Yeah.
I can see that.
Okay. So basically, job scheduler to run. So here, what we are doing is like we are taking some requirements, right? So job scheduler to run bash script.
Yeah, you can let it just run the bash script.
Mm-hmm. And so what would be the average time of average time to process? Do we want to define like how long average time should be, or it should be configurable?
Yeah, average time is 1 hour, and yeah, the actual time depends on how long the bash script runs.
Mm-hmm. So when you say average time, it means like after every 1 hour it will get invoked.
Hmm. So every time, just average, how long the job runs usually. And the new job, you can assume that there
But it should
every
be.
10
Mm-hmm.
every 10 minutes there is a new job scheduled.
So average hour of execution is 1 hour.
Mm-hmm. It can be less, it can be more.
Okay, and new jobs are scheduled every.
So here is the thing. So new job schedule, that doesn't mean that every 10 seconds there's a new job coming. It means that on average, so this is still the average, that every 10 minutes there's a new job coming, but each job can be have some pattern, like some job is scheduled every 5 minutes, some job is scheduled every hour, some job can be scheduled every even longer. So all the number here are average.
Okay. Okay, I would say uh, so. So is it up to job? It's a configurable parameter for a job, like to.
Yeah, you can have the job like the pattern, running pattern, and the entry point.
So it is a config parameter. How it will schedule.
Yeah, something like cross style job, like every 5 minutes and something a lot of stars. I can remember that and the entry point. Entry point, something like this.
Yeah, and it could be even more. Okay, and this could be and this could be in minutes only, or like every 5 minutes. It could be like a month, Monday. Like generally, the pattern is like every Monday is 8 a.m. or it should run between Monday to Friday after every 5 minutes.
Yeah, that can be that complicated.
It can be there. You're telling like it could be there.
Yeah, it could be there. It could be that complicated.
So examples are. I'm just putting some example, like it could be Monday to Friday every 5 minutes, right?
Yeah.
And there could be many more examples. Different combinations are possible. I know it could be every Monday, it could be like that, but okay.
Yeah, something like you can reference for the Cron. Very similar.
Okay. And let's take some. So do you think any other requirements, or we're good? Or you want me to think more about any requirements?
Another requirement I can think about that. So we can have some limits. So it runs every 5 minutes. So we can let the like if it's delayed 1 minute or earlier, delayed 1 minute or 2 minutes is not a problem, because a lot of job can be
are you
scheduled
telling
in.
like a throttling kind of thing?
Yeah, so maybe that's the word, I'm not sure.
What
Like
did you say? Can you repeat?
Yeah, I'm trying to say that there could be some moment that a lot of job scheduled at a time, a certain time. So I would say that we may not have enough machines. So we can let some jobs delay 1 minute or 2 minutes.
You mean that based on the priority?
Yeah, very good. Yeah, I think that's how it is.
We don't need to set the priority now because this is some additional feature.
Right now, the priority is first come, first serve. I mean, you have.
Yeah, we can
What you are
schedule
saying
that.
is you have limited machines and resources,
Yeah.
and if there are multiple things coming up, you have to decide that which one can execute and which one can take the machine resources. So
Yeah.
it will be based on the priority, and now here the priority is who comes first, he will get that that machine resource access.
Is that for a single machine or a distributed system?
It's a distributed system.
Then why we have limited? I mean, why, could it be more like, scalable? Need to scale out if that's needed, and if it fail, we have to handle it. It run, let's say, for an hour, and what happened if it fail? And are we gonna retry it?
We are going to retry because we don't have. We need to assume that we don't have enough budget to buy enough machines, and if we fail, we can retry because all the job we can assume that.
So if a job is failed, how many times we should retry, or it should be configurable?
Yeah, let's assume that every job have a timeout, and if the job declares it failed, or after a certain amount of time it never responds, we can assume that this job fails. And for the failed job, yeah, if job itself fails, we assume that the job it fails. Otherwise, if the job doesn't have the response after the timeout, we can retry the job.
Okay. Sorry, so there is a threshold, right? Okay. So
Okay, and
we already told like threshold would be an hour. If it doesn't respond, then we'll just retry.
Yeah, only when it doesn't respond, or
so retry from the beginning, start all over again, right?
Yeah, that's right.
Yeah. Okay. And then I know that the batch script is the input. What would be the output? How would the output we notify the user? When the job doesn't know what the output going to.
We can have the API to check we can have API to check the results, including the log, including the any result.
So we need to notify the user when it's done.
We don't need to, even though we can, but it's not part of the design. It's not a very important feature for us now.
Okay.
I think the only notification that we should be concerned with is the scheduler should know, right, when a job successfully executes.
Yeah, only the scheduler need to know that the job
so that it doesn't have to retry the second time or whatever time.
Exactly.
So okay, there could be a design discussion, but here we are just trying to retry failed job, and how many times? Like I can put like 3 times it should retry.
Yeah. So anything that is not the job's fault, we need to retry. Like the machine is down, like network is not available, like other things.
Network is okay. So fail definition is like you're telling like apart from job. Okay.
So yeah, actually for the job itself, we may not need to
retry
know
if there's
it failed.
exception in the job.
Yeah, if the job is finished, it's finished.
Okay. But if the job failed, or like there are some errors in the job, what would you do?
Yeah, if the job itself fails, we don't need to do anything special. Because in reality, usually we can let the job to retry, but here that's not to do that.
Okay. But if the threshold exceeds, then we'll retry.
What's that?
So if the threshold of 1 hour increase, then we'll kill that job.
I don't understand what you're talking
about. So for
example,
if the threshold is like 1 hour to run a job, and if the job is running for an hour, we'll kill that job.
That's right.
Okay, and then
retry for like 3 times.
Yeah, we can set it.
So the job can be done by a single machine, or the job scheduler need to schedule multiple machines and aggregate the result.
No, that's too complicated.
Yeah.
And we can assume that each job can run on only one machine.
Okay.
And how many jobs we are expecting to come? Like how many jobs can be coming in like a minute? Like how many total jobs could be, and how many we are expecting to coming in a minute?
Yeah, so on average, the jobs comes every 0.1. So every second there will be 0.1 job. So you can have the estimation of how many jobs are running at the same time.
So every 100th of the second, one job is coming. That no, every 10th of the second, one job is coming.
Every 0.1. So every second there's 0.1 job coming, and the average job, the time for each job on average is 1 hour. So you can have the estimation how many jobs concurrently running. So basically, like this is the queue problem.
Sorry, what you said?
Oh, this is a queue problem.
Yeah, but I'm just trying to simplify the calculation for me.
Yeah, 0.1 times 1 hour. I think that's a good enough.
And I say like one job coming per second.
0.1. Because you'll see the number is very high.
Okay. And then in 1 second, how many?
10.
And times 1 hour, so that is 3,600 seconds.
So in an hour, how many we're getting? Like it would be like 360 jobs per hour.
Yeah, every second there are 360 jobs running.
No, this is per 3,600.
This is second
in an hour. So if
no,
0.1 is
3,600 seconds per hour.
So 360 jobs per hour.
Yeah, that's what I also felt.
Wait, what? Why you have this conclusion?
Because if there is 0.1 jobs per second and there are 3,600 seconds in an hour, I just multiplied and got 360 jobs per hour average.
Yeah, that's also true.
And how many machines we are like?
You can have the decide based on the requirement.
average, how much time per job takes? Like it could be like, I can say,
It's say an hour up there, right? On line 4.
okay. So if that is the case, then I need 360 machines at least to get started.
Yeah, that's right. That's at least for both the machines.
And then things can go here and there, which we need to take care.
Mm-hmm.
Okay. Any other thing which coming to people's mind, which should be covered here?
What is the non-functional requirement here?
We are just talking about the load and the threshold, which is not the functionality. So we're just trying to calculate what is the load and other things.
Yeah, if you put a non-functional, people may think that this is because pre-section you have requirement, and next section they may think that that could be the non-functional requirement. So you may use some different word, I guess.
I thought
I think this is a functional requirement. Like, I mean, this is the main functionality, right? That you need these many machines, and all non-functional is that you just like you have some you want your system to be better in some sense that it can
see again.
This is usually people understanding of what is non-functional requirement. Like we may need to have the chain job, or we want to notify the user.
Yeah, right. Making your system scalable, maintainable, and reliable. All these things are non-functional requirements.
Yeah. So maybe we can change the title of line 16 to be estimation.
Yeah.
Or I don't know what's a good word for this.
Yeah, estimation sounds better.
But I feel like estimation and non-functional overlap, because based on your estimation only you decide like how much scalable I want, or do I need more machines, or whether I want actually 360 machines, or again I don't feel this could be like a requirement, because this could again change like average times and other things.
Yeah, this is something that we will need to decide how big the system is, how the system look like, how many machines are going to involve, how many other machines, how we use your database, where we choose a certain pattern of the database design, all kind of thing.
And even like in the starting, Leon asked like, can I do with one machine? Here I able to find out, okay, I can't do with one machine.
Yeah, that's a very strong justification where we can't use only one machine. Otherwise, the interviewer will tell you why you're using one, because we don't have enough job to run. So yeah.
Okay. Any other things people want to discuss? Or we shall jump to like a high level design?
Yeah, I think we are pretty good. We can have the high level what the system look like.
Okay, so what I was thinking, one, we have a client and we have this. So basically I'm thinking about different components of the system. And one component is which is like a job, which will just accept the jobs. So basically you can create new jobs, and which would keep that in the database. I'll come back to the database schema, but this is the system which will just accept new jobs. So basically any job maintenance, it will do like add new job, or remove job, or What happened?
Yeah, this is sounds like an admin system.
Yeah. Oops, sorry. So basically here I could expose different endpoints like add job or remove job, or I could say edit job or suspend job.
Yeah.
And behind the scene, I would maintain the different. I would maintain different jobs on the like some in a schema where I'll have a job ID followed by whatever we call like a bash script, and followed by, I should have done that up here. Never mind. Sorry, I'm using these tools for the first time. So basically,
yeah, it's better to use iPhone or iPad or any tablet to draw the picture.
I have a pen, so I'm using it for the first time, so might be that reason.
Okay.
So job ID, like this bash script, and then we want like the frequency, status, whether it is deleted or suspended. It would be like something like ready, or could be suspended.
Yeah, actually, you can put this text in the coder pad. That's easier to read.
No, I'm pretty much done here, and
okay.
Then it would be user ID who has created that. Okay, and then there would be another component which would be doing this, which would be this would just like a job scheduler. And it will take all the so what I'm thinking is it will take the jobs which are there and it will, okay, before that, and there will be set of different machines which would be running the job. And I was thinking like it will be putting the necessary jobs in a queue. And then these machines would be subscribing to that queue or reading different jobs. Yeah. So
and keep in mind that the interface to know the status of the job will be of very high pressure.
Which one?
Yeah, so people need to know the status of the job, and also because you have this one job scheduler to manage so many machines, so potentially there could be a single point failure. Yeah, so for example, every month we may need to patch all the machines. So if you patch the job scheduler, the whole system will be down.
Yeah, that I can handle. Job scheduler could be like primary and secondary. So it could be like have its own primary, secondary setup.
Okay.
So if one goes down, the other will come back. But it is not maintaining any state. It's just a scheduler. It is just putting in the queue. And once it is in the queue, once a job is done, it will every system will write back to a different queue that this job has been completed.
Okay.
Is the queue sit on the same host as the scheduler or on different machine?
It could be a different machine, or we can use some cloud-based service. That's what I'm thinking. It could be like a SQS.
Okay. Yeah, that makes sense.
And what other thing I'm thinking, like so right now I didn't make and okay, once a job is completed, it will push into a different system, and we can have metrics and telemetrics and dashboards on top of it. So
Okay.
other thing what I was thinking is so for example, let's take a scenario. This guy gets a job, and it got if the job is failed, it will write back to that queue that with the job status failed, and if the job is running for more than an hour, it will kill it, and and it will kill it and put it back in the queue for one more retry.
Okay, who is going to put the job back to the queue if the, for example, one of the worker is down and it cannot do its job, and it cannot actually tell the job scheduler that you need to re-enter re-in-queue the job.
Okay, so other thing is basically it yeah, that's a good point. So I was having an alternate approach here that like we told, like the average time is 1 hour. So so every item will have a visibility. As soon as it gets picked, it will get invisible for an hour. And we also maintain retries here. So basically, it will wait for the acknowledgement till it is done. Otherwise, it will remain in the queue. Basically, if this guy is done, it will remove it from the queue. Otherwise, it will get retried after 1 hour. And the maximum retries on that guy is 3. Does that make sense?
Okay, can you write some workflow of this thing? I think this is the most important of this system. Like what if the job fails? What if the worker die? And what if all kinds of scenario? How do we can make sure that job is running?
Okay, so let me
also I have a question here. Is it relevant to talk about even like the algorithms, the possible algorithm that can be used for dequeuing? Like, is it a first in, first out, or, based on the balance, if the scheduler is trying to maintain balance between the workers, right? You don't want, or is it?
Yeah,
like
I think that's,
yeah.
Yeah, that's right. I think in some cases, we may not have enough machines to process all the job in the queue.
Right.
Yeah, so that's fine. We'll keep our jobs in the queue, and the flow. What I was telling was, as soon as it is picked by a runner, this so this will get invisible for an hour, and if the runner is able to success, so if it is success, it will remove that from that queue. Otherwise, after an hour, it will get picked up again.
Now, what happens if the worker that's running the job, right, it fails? Then you are that job won't be deleted from the queue and it will be picked by another worker.
Yeah, it will be picked by another worker. So max retries are 3. That's what we decided.
So how can you guarantee that when the job is picked up by one worker and it will later pick up by another worker?
Yeah.
No, so if the R is exceeded, and this guy will automatically kill that job, right?
So the scenario is that the worker picked the job, it finished it, and then it went down. So now your job is finished, and now your queue will see, oh, that the job was not finished. It will reschedule it.
Yeah,
the
because
job
it was not
finished.
able to communicate. It was not able to communicate back. So that's why if I don't have acknowledgement, I have to retry.
But then you're doing the same thing 2 times, right?
Yes. And that would be like expected here. If the worker couldn't communicate, how I will know it? It could be.
Can you check the complete job?
See, here the question, here the ask is the job is completed and the worker is died. It didn't tell anybody outside world that I'm done.
No, because it could have been say okay, it complete, right? It put a job in the complete job, but then before send the acknowledge back to the scheduler.
But maybe
let's say the schedule, and then
that I will say
send
I would say that is a really edge case. So worker was done with the job, able to write back to completed, and then it failed on telling back to this queue. I would take that as an edge case.
Yeah, there's a term. Yeah, there's some term called idempotent. I'm not sure if you guys heard about that.
Yeah.
So even though the job may succeed internally, but it may not have the chance to tell the scheduler or whatever to say that I'm done. So it may consider itself still not successful, and the scheduler can choose to reschedule the job again, and there won't be any difference in the final result.
Yeah, okay, I got your point. So I think what you are saying is that it's the duty of the job, like a person who is giving the job, that his job should be idempotent, so that if the job is scheduled again, it should not do the operations again, right?
That's right.
Yeah.
They may have some key to say that this is for a certain job.
Yeah, actually we are doing exactly same thing in our code in my work. So yeah, our job is that idempotent job, so which even if it is scheduled again, it won't do that same.
And I think that is the expectation. If it's doing something, I think stateless system should be idempotent, because we don't know.
Yeah, actually not all the systems doing this. My job, there is a build service, and most of the job are not fixed, but they can be retried multiple times.
Yeah, yeah. I mean, we have to ensure in our code that every line of code we are writing that code is idempotent, so assuming that it can be. So we have to be conscious about it. But
yeah, that is a requirement for the job itself.
Yeah, job itself. Yeah.
Oh, where are we?
Okay. We were there, like the runner. So runner picked up a job. It put that in the completed and removed from the queue.
Oh, so you're saying that only when the job it considers itself complete and submit the result, then it will dequeue the job from the queue, right?
Yeah. So that is the end-to-end flow. If we couldn't able to write here and delete it first, then also it's a problem.
So I wonder that does SQS or any queue support a feature?
Yeah.
Okay, I didn't know this.
So does it also support like no duplicate job in the queue?
Duplicacy would be controlled by the job scheduler.
No, but there's no guarantee. Yeah, because we have only one scheduler, right? So there's no duplicate. But Okay.
And
Because
I'm
for
not
the SQL queue, it's not guaranteed that they will remove. It's not guaranteed the message will be unique, right? That means it could be a duplicate in the.
See, if scheduler put a duplicate message, then it will be duplicate.
What do you mean that as won't guarantee the job is unique? So if
Like you can
queue,
put two identical job, into the queue.
And
but
there will be 2 items out. I think
Yeah.
this is reasonable.
Because that is not a queue responsibility to find duplicates. It will be overkill for the queue.
Also, the item potency concept, right? I think that should be able to. It may not prohibit duplicates, but at least it can ensure that even if the message is processed, like there are 2 messages same, even if they're processed by 2 workers, the results won't conflict, right?
Yeah. In the reality, that it is possible that 2 workers are processing the exact same job. Like the first worker may doing the job, and the next work is done, and they have no chance to go back. And another job, the job is scheduled for another worker, and ultimately both of them tell the scheduler, so this job is done. It is highly possible.
Okay, so.
And one thing I'm not really sure I want to double check is that does the SQS support that mark one of the queue items to be in progress?
Yeah, so basically it has a kind of a counter where how many times it is being read by a worker. So it could increase like 1, then 2 and 3, and then there is a threshold. So you can put a 3, after that you can send it to other queue.
Okay. Interesting.
I also have a question here. Is it possible that we were talking about this issue that a job starts processing on one of the workers, and let's say it's finished, the job finished, but it didn't communicate back to any of the components. So in this case, it will be processed again and all of that. Is it possible that, like depending on the nature of the jobs, right? That there is a component between the queue and the workers where the job can be further split into tasks, right? Unless we are considering job as an atomic unit. So if I can split the job into tasks, and let's say one of my tasks is, process like P1, P2, and then the last task is the email notification or something, right? And now let's say I completed, initial tasks except the last one. So rather than moving the whole job to the end of the queue and processing it all through, would that give us, I'm thinking that can give us benefit, right? That I can maintain that only the last step failed. And if I can just process that rather than the whole job, I don't know if that's even practical, but.
Yeah, that's very practical. But I think we need to leave this design simple so we can assume that every job here is actually a task.
Okay.
And in reality, I know that usually a lot of schedulers support the chain job. So that when job done, it succeed or it failed, it will go to different paths, do different things.
Yeah.
And it is supporting a lot of workflow system.
Right. Yeah.
Okay, so I have a question here. Let's say, you have job 1, right? And job 1 is being processed by worker 1. And, worker 1 take more than an hour to process. So, job 1 now become visible in the queue and now pick up by, worker 2. And worker 2 also take, more than 1 hour because let's say, some, conflict with IO or waiting for something, right? If that's the case, then, we will have many workers working on the same job, right? And nothing being done. Eventually, we may do nothing. Our worker could try to process the same job. So how would we prevent that situation?
Yeah, that's a very good question.
I think one of the things might be that after 1 hour time window, right, when the job is ready to be picked up again, we can have some like tracker, right? If it's like, what's the status, rather than just being picked up blindly after 1 hour window. We definitely don't want to have another worker start the same job again if it's just that the job is like 1 hour 30 minutes long, right? So maybe.
Yeah, I think
So
that's where we have
how
time
would
off.
the scheduler know, right? So are you saying the scheduler would need to know, like,
Yeah, so
who processing which job?
Yes,
And then,
yes. So I'm thinking that when the job is picked from the queue, at that time, so when let's say R1 gets the job, picks the job, and there might be a small acknowledgement packet that's sent to, there might be some other component, I don't know, or maybe it sends it back to the scheduler, which tells it, okay, these are my actively running jobs, right? So job 1 is being run on worker 1, and the token or something like the current status is running. Now, when the window expires, 1 hour expires, then before the job being picked up again, it should check, maybe poll the worker or check what's the status. If it's still running, then don't just pick it up, move to the next one.
but that would be kind of tightly coupled between the scheduler and the worker, right? We should decouple them, scheduler should know the worker and vice versa. That's why
Yeah,
we use a queue.
yeah, sure. I'm saying that there has to be some component, like, right? It's the scheduler which is picking the jobs from the queue and assigning to these workers, right? So our question was that when 1 hour expires, again, it will be the scheduler which looks at the queue and tries to assign it to one of the workers. So according
No. Here, a scheduler is not doing anything. The worker itself is deciding.
polling and picking that up.
Yeah,
Okay.
scheduler is only putting in the queue. That's it.
I see.
The
Okay.
scheduler, his job is to look the frequency.
Okay.
And look the timing, take some decisions, and see if it is the time for the job. It will just put that in the queue.
Okay.
Yeah, I think in this case, the scheduler still need to know the health of the worker. So worker may do the most of job, maybe run the job and decide if the time out, but periodically you still need to send the heartbeat to.
No, so that's what I'm saying. The queue itself will take care of that.
Queue itself.
Mm-hmm.
So is this problem? Yeah. No, I was saying, is this problem solved by this exponential back-off thing, that if I'm failing, I won't retry. So my failure time is 1 hour, right?
Uh-huh.
So I won't retry exactly after 1 hour. I will, if it is my first fail attempt, I will wait for some time. If it is my second retry attempt, my back off, the waiting time will be more, so that the same job is not.
The case I'm describing is not failing, right? Because if you're failing, that's only one worker doing a job at a time. I'm saying that it take because of it takes longer to process it, and because it have to wait for the process or whatever, and that's why worker 1 still processing this job and working the same.
But for the queue, so if the job is long running in the queue, we are seeing it as a failed job, because in queue we will have put that this job is not completed after 1 hour. So for us, it's a failed job, right? Although it's running.
Yes.
So I'm saying, rather than picking that failed job immediately, which is also running, but rather than I'm looking at the queue and saying this job has failed, I will picking up immediately. I will have an exponential backup thing that I will not pick up immediately. I will wait for some time, and then having that such count that how many times it has been retried. And by retry, it does not mean that the job has failed, it is running, but to me it appears that it has failed.
Yeah, so but in this case we have only three, right? If we do exponential back off, then, it's going to take a long time to process, because we really don't know, not processing the state of the worker, because we don't know if not get it done because of, fail, or because, waiting for something, or, for some other reason we don't know.
Actually that brings, so yeah.
Can I have the use case again? So what we're discussing here is, let me erase something.
So I think that the exponential backup makes sense only in the communication. Like we may try to reach out some results and give me a timeout, so we can try after 10 seconds, after 30 seconds, to make it longer, and we can declare either we fail or we succeed. And for the timeout of the job itself, I think it makes sense that we just simply say that if the timeout is 30 minutes and after 30 minutes we don't see any result, we say, okay, this job fails. The worker will shut down the job immediately and tell the scheduler say that this job failed.
So
we also have
I haven't designed it that way. My design was that it will put a message in the queue. The message would be read by this scheduler. This message will become invisible for 1 hour or whatever we have defined, and let's say this guy. So this, let's say this is done in 30 minutes. So it will write back to completed one, and here it will remove that from the queue. Let's say if it is already exceeded 1 hour, the runner itself will kill that job and don't do anything. And let's say this message again picked up after an hour. This message again picked by this guy. Again, it took 1 hour. It will cancel that, and here the count is also getting increased. Now the count is 3. Now this message is again picked up by third one. Again, it took like 1 hour, and then once it reaches the threshold, the queue itself will remove it from here and send it to this another queue, or it will send to some other queue.
But what is the point, right? We have used 3 resources trying to run the job of 1 hour. Every time we are killing it after 1 hour. Then I think one of the ideas that Abhishek brought up, that if the job gets killed after 1 hour by one of the workers, can't we just, maybe increase this window of visibility, let's say to 1.5 hours, so that maybe the job just needs 15 minutes more?
No, that was our requirement. Now we're talking about the flexibility. So that will be a separate design. So as part of our requirements, we discussed this thing. Threshold is 1 hour, kill the job.
Sure.
I would say in reality, like in my system I'm doing, we never treat it like this way. If they pass the timeout, we treat it like it's done, it's over, it failed.
So I have seen there could be alternate design, but that would be a different thing. I have seen in the past somewhere like, okay, it could be like it would not be hard threshold, it will like a soft threshold kind of thing. As soon it will reach like 45 minutes and it sees that the job is still running, it will communicate back to the queue. You just increase your timeout for another 15 minutes. Visibility timeout. So, but that is like a totally different design. But here we have already decided like, okay, 1 hour done, just kill it, let it get retried again.
Yeah.
I have one scenario that can be actually, I don't know what's the time window for our discussion, but just a thought here, like, when a job is running, let's say it needs some resource, right? I'm thinking a little bit, this is very common in databases. So I'm thinking like it needs some resource, some input output resource. Now the job, even though it's assigned to a worker, but it's stuck, right? It's waiting. So instead of keeping it there and let it spin, like an hour and then fail, right? Because that is just stuck on IO. So we can have another queue called, wait list, waiter, something like that. So that any job which is, waiting for a resource, you can move it to the queue, to that wait, right? Otherwise, we are just like, giving a false sort of illusion, right? We can think of these workers as CPUs. So jobs are assigned, they are running, but what if they require some access to IO which is not available?
Yeah, this is something like my understanding that this is the job of the scheduler to find the right worker. So some worker may have their configuration, like some workers may be strong at CPU work, and some have the fast network work. The fast network bandwidth. So the scheduler may put them all into consideration and choose the right worker to do the work. Yeah, I would say that it's something like in reality we can do, and it's a feature of the scheduler. We don't need to discuss here, but definitely in the reality system, this is a very popular feature.
Yeah.
So the scheduler is the one responsible to queue the job if it needed, right? Somehow have to have that reference to the worker, right?
Yes, scheduler should know the status of the worker, which are working, which are free, I believe.
In my design, I didn't think in that way. If I put like few component as part of scheduler, then it's fine. But a worker itself is responsible of picking a new work. If the queue is empty, it will poll and then will not do anything.
So so all the job pull from the queue and yeah.
I thought in that way, but it could be like more responsibility of the job scheduler. But I couldn't think how it will work. Then it should be knowing all the workers which are there in the system. But I was thinking like there would be another component outside this, which would be checking the health of the queue, number of messages and other things. And based on that, it will add more workers in the system and remove more. So if the queue is empty, it will even remove the workers.
Yeah, I think that's also reasonable. That if the schedule knows how many jobs are active, then they can do it ahead of time, because usually provisioning a host needs to take some extra time.
Yeah, it could be host or it could be like a Dockerized one.
Yeah, Docker also need to warm up because you have to pull the image on anything.
Okay.
So anyway, also Docker it's based on the compute resource. So I'm not sure you may still need new resource to run the Docker.
So
okay. Yeah. So how do we handle scale? Right now, let's say the job schedule can handle, let's say, 1,000 job, right? And now we want it to handle 10,000 job. What we need to scale out?
We have
I think that's make this job schedule powerful.
Powerful? Then would that be a single point value or
so
no, not right? We already talked about the replication. Okay.
Yeah, I'm thinking that we may need to use multiple schedulers to schedule the job.
There could be multiple schedulers also, and although they are writing from they are actually picking something from the DB and maintaining the status, like what time they have what time they have executed. So other scheduler can also go and read and ignore that.
Yeah, so can you tell us more about how you're going to design the DB so that the job scheduler can pick up some
that
new
is
job?
One thing I'm also thinking, which I think I missed at the start. So let me...
Let's use the coder pad because this is another interesting part of the system.
I would try to write here and see if it works, otherwise I'll move to coder pad. So what we thought about like a job ID and so what I should call it, I couldn't think. It should be like what I can call this. So basically I'm trying to say like a sleep time kind of thing. I couldn't think about any other better word.
Mm-hmm.
Like it could be like 5 minutes or whatever. And last executed time.
Okay.
I could switch here on. So what we thought about like job ID and pattern.
So this is a configuration of job.
Yeah, it would be like we spoke in the start, Monday to Friday, something like that. Every 5 minutes. Then last executed time and status ready or like active or suspended and like a user ID. And it would be like bash script. Okay.
Entry
So
point,
basically,
I think.
Mm-hmm.
Bash script is more like entry point, right?
Bash script is like whatever is there, it will pick up and put in the queue.
Okay.
So what I was telling was like script to run. So what it will do, so this is interesting point. So what it will do, it will see what frequency it should be, and then take it last executed timing based on that, decide whether to put that in the queue or not. Would you think it will work, or it is having a lot of issues?
The schedule, is it based on the client time or based on the
It was a server time.
scheduler time?
It would be based on the server time.
Yeah, and also keep in mind that the time in the scheduler may not be very in sync, so they can be different.
No, here we don't need what is the clock time. UTC will also work.
No, I mean even the UTC time in between different schedulers, like from the Arabic cluster, and they can be different.
Okay.
I have feeling that somehow we're not really guaranteed that the job will be done, will be scheduled at this particular time, because
exactly.
Yeah, we did not like the level of agreement. Somehow we have to make it closer to the scheduled time.
Yeah, even the schedule, even the closer may not be actually very necessary. The requirement from the MapReduce job or maybe from the Lambda job, let's say, run it every 10 minutes. And from which minute, I don't care. And if it's every 11 minutes, every 9 minutes, it doesn't matter in most cases.
Yeah, but like for certain system, we might need to like run exactly at this, you know, let's say if I schedule this to run at, you know, this time, and, you know, I want to run it at that time, right? Not not earlier or not too, you know, later. How would this system guarantee that?
We just say that our system don't need to guarantee this, so that's accurate. It doesn't need.
Then, you know, then it's like a regular queue job. They can execute at any time, right? You just put a job in a queue and execute, you know, at any time. Even if we retried it, it doesn't matter, right? Because let's say, suppose I say, okay, run the job in, you know, every hour, right? If I schedule job run hour 1, 2, and then, you know, if this one fail, then we reschedule and run it later. But, you know, at 1 hour later, I already have another job running. I don't want the result of the, you know, previous one.
Yeah, that's right. If this is something, we can have the flag to say that non-overlap or something, so that if the job is already running, we don't start a new job. So yeah, we try to run it, say in the case every 5 minutes, but we may delay.
So are we saying that here it will also, so job scheduler will also, like, let's say it will go to a queue or followed by a table. It will also look both places and decide whether I want to schedule it or not. It will take 2 decision points.
Can you put an example of that this little thing into the CoderPad? What kind of thing you want?
No, so I think here I heard the discussion that if the job is already running, then don't put it again in the queue.
Yeah. So, if you think it's too complicated, we don't need to design that.
Yeah, I think we are already over time. So
yeah, I try to make this 1.5 hour.
Okay. I think somebody told in the chat it is 1 hour.
Oh, really?
Okay, never mind. So we still have 10 more minutes. Okay, so either, yeah, I think that are all valid points. Whether I want to reschedule it or not if already job is running. So that's what I was telling, like once the job is completed, deleted, suspended, it will also check what is our latest status. Do you think that will work?
What's that?
So we'll have like something like a run number.
Status.
Like
current.
A counter, and then we'll have that other place where we have that job ID and run number. So it will. So are we saying like there would be another table where it will maintain whether that job was finished or not? Then only schedule a new one.
Oh, okay, so this is a new table that maintains the any running job.
No, it is not that. It is like it is the extension of what we saw here. So once anything which reach here, which will go to some table, right? And we can query that, the job scheduler can query that table to find the status.
So this is some job finished.
Job finished or error out, anything. Like something happened to that job and that job is done now.
Oh, okay, I see. Yeah, probably we can do that.
Yeah, only that thing coming to my mind. I couldn't think anything different. Okay.
Yeah.
But I'm still not that much clear that how well pick this. Like you mentioned, there could be clock differences and
yeah.
Do you think this
very
design will work if I just say 5 Monday to Friday after every 5 minutes? It will see last executed time, and then based on that it will take a decision.
Probably we can I don't know what was the best way to do that here.
But that means this job scheduler will be pinging the database after every few seconds, or like even every second, or less than a second. It will keep on checking, or do we want some other kind of mechanism?
So I was thinking about we are doing a lot in just trying to maintain and figure out if a job status is complete or not. Rather, like what I was thinking is just to abstract out the logic where you have to keep a status of if a message or if a scheduled job executed or not. So you can just push a message to the SQS queue and let it do its retry based on if it's a success or fail. And then after 3 retries, it'll just stop. At the same time, the scheduler doesn't need to know about if a job completed or not. Its primary responsibility is just fire off the next job whenever the time comes, and then at the same time when it fires the job, it also calculates what is my next trigger time for the next job, and saves only that information. Because I think the tricky part here is trying to figure out if a job completed or not. We can just abstract out the whole thing out of the scheduler and let the SQS figure out if there's any kind of error when it's actually trying to process the job. If there is, you can configure all the retry stuff there and continue.
I think the original ask was if the job is already running, don't put a new job. But I see your point. Like it's not job scheduler responsibility. Job scheduler is to schedule cron it. That's it.
Yes. Okay, but the thing is, it's going to take an hour to complete. So, but then the frequency is also like every, I don't know, 1 minute, 1 second, whatever it was, right? So irrespective of whatever it is, like let's say it runs at 10 a.m., right? At 10:01, there is going to be another independent job that actually runs. So both of these things are not connected. So you just like trigger a job, push it to SQS. SQS handles the retry stuff based on if it passes or fails, and then it continues from there. Like the scheduler doesn't need to know about the status of each individual job that's executing. Its only responsibility is execute a job, or I don't know, push a message to SQS, calculate what is the next time that it has to run, and store that information.
So I don't know. Put that time here only somewhere.
Yeah, probably like you can have something called next fire time where basically it updates it when it executes a job. So it's going to push an SQS message at the same time, calculate what is the next fire time, and just save the record in the database.
And how frequently this job scheduler should query database?
It doesn't have to query the database for any kind of status, right? So it's
no, it is not querying database like next fire time. And it has to find what if I've already passed the next fire time. So think in that way, like I have 5 jobs out of that 3 jobs have now next fire time already passed. Okay. So job scheduler should be querying really frequently to find out what are the next jobs to put that in the queue.
Yeah, that's true. So
Mhm.
I think like whenever the next fire time is actually passed, right, the scheduler needs to find out like how do I actually trigger a message, right? That is in and itself another question. So I haven't thought about that, but I think I had it thought about until the point where when it's time for an execution, uh, the the machine that's actually taking care of the execution will say, take this bash script and push a message into SQS and then let it trigger, um, and then also calculate the next fire time for it, and then save it into the database.
But now my question is like, what kind of model will, what kind of model, or what kind of model we should follow for this? I what I was thinking, what what I was thinking was little different. So I was thinking that job scheduler will run after every I'll say 1 minute, or let's hypothetically take 1 minute, and finds what are the next things could be done in that minute, put all of them in the queue with some timeout visibility.
Okay.
So basically, if anything which has to be executed in next 60 seconds, based on, and it will do the calculation also, like in 60 seconds, what time it should be after 30 seconds, put that in the queue with that visibility of 30 seconds and be done. Or there is another thing in SQS. It's not visibility timer. It's like when it will actually be go into the queue. You can even control that. You can actually send a message to queue, but you also tell like after 30 seconds only it should enter the queue.
Okay.
So that's what I was thinking. Then job scheduler does not hit database every milliseconds or nanoseconds. It will hit after every minute, do some calculations and send it to SQS like a batch. And based on their next runtime, it will take some decisions. I'm just trying to see if I missed any
Yeah, I
point
think
or
that is
not.
also a good idea. Yeah.
Okay. So you guys do want to talk about this next week? Same time?
Sure.
Yeah, I think this is a very interesting topic of this
Yeah,
queue.
it's like out of I think box topic. We always talk about a lot of application design, but this is really
Yeah, this is a very interesting
uh-huh.
thing that the maintain the queue and maintain the worker. Very, but yeah, there's a lot of discussion. So okay, so let's stop here and let's try to talk about the queue specifically next week.
Okay.
Sound okay?
Okay, sure. Thanks, guys.
All right.
Okay, and
Okay. Thank you, guys.
thank you guys. Thank you, Aseem and volunteer for this discussion, and anyone involved in this discussion. And see you next week on Thursday at 5 p.m. Pacific time.
Thanks.
Okay, bye.